8th honors class and also 8th regular class, I want to go over some of Miss Katz's notes for exploring quadratic graphs. This is the next lesson we're going to work on. When we factored last lesson, what we were really doing was the math behind the graphs that we're going to see in this chapter. They're quadratic graphs, which are going to curve, like this one looks like it's curving here. These sorts of graphs are never going to curve left and right. They're only going to curve either up or down. So they're either going to look like U's or A's without a cross. For quadratic equations, standard form is as above. So y equals ax squared plus bx plus c. Another way to write it is f of x equals ax squared plus bx plus c. F of x is basically another way of saying y. It's when we plug in something for x, what happens here? Same thing here. When we plug in something for x, what happens to y? What number does that become? Ax squared plus bx plus c is just like having 3x squared plus 4x minus 8. A is 3, b is positive 4, and c is negative 8. It's as simple as that. So the a corresponds to the number in front of the x squared, the b the number in front of the x, including the sign, and the c the number after everything with no variable next to it. These shapes are called parabola. They're curves up and down. They start shallow and then they start moving up very steeply. These are because of the x squared term here. As this number increases by 1, this whole term ends up increasing very quickly. If you have 100 for x, you have all of a sudden 10,000 there times whatever that is. So that's why this starts shooting up very high. Y starts to get very big with a very small increase in x. We're going to learn how to find the axis of symmetry for parabola. Axis of symmetry is the thing that cuts it right in the middle. The axis of symmetry is always going to be x equals something, because the axis of symmetry is always going to be a vertical line, and a vertical line always has an equation of x equals something. It does not have a y component. So a vertical line is just going to equal x equals something, and that's also going to be how we display our axis of symmetry when we're doing a problem. To find the vertex, that's actually the place the parabola starts. So in this case, it would be right here. That's our vertex. What that is where the axis of symmetry crosses the parabola. So once you find your axis of symmetry, we just plug that number in for x, and we solve for y, and that's going to give us a point, which is our vertex, whatever this point may be. Let's say here it's 2, 4, or whatever. Although, you know, this is not to scale. I have no coordinate. I have no axes, so this is just a total complete example. Any parabola that opens up is going to have a minimum point, means it never goes below this point right here, its vertex. That's considered a minimum. If you have a parabola like this one that opens up downward, that's going to have a maximum point. So when if you think of the arrows of a parabola pointing down, it's going to have a maximum. When they point up, it's going to have a minimum. So up is minimum, down is maximum. If you're asked to graph a parabola, you can always, and when you need to graph anything, you can always just plug in points on a t-chart. So you can do an x and a y and plug in different points. I recommend you plug in at least 5 for these, because you have to, when you're doing curves, you have to make sure that you do enough so you can actually see a curve. 3 points is probably not enough. So if you were asked to graph this, you would just plug in all these different things for x. And remember, whatever you plug in for x goes in those parentheses and gets squared before you multiply it by 1/2, because of the order of operations, PEMDAS or GEMS or whatever. You're doing exponents before you're doing multiplication. So whatever this x is, you put that in there and square it, then you multiply it by 1/2. What this 1/2 is actually going to do when you graph your parabola, versus let's say we just had y equals x squared. I'm gonna start a little new page here. If I said y equals x squared, that's going to be, if that's our x and y axes, if we had y equals x squared, it's probably going to look something like this. if we have y equals 1/2 x squared, whatever this term is, it's not going to go up as fast because we're multiplying it by 1/2 instead of here where we're multiplying it by 1. So this one's going to open up a little bit less fast because it's kind of being cut in half every time. If I said y equals negative 1/2 x squared, that's going to open up downwards, but the same exact way as y equals 1/2 x squared, just a mirror image of it. And then if I had y equals negative 4x squared, what that's going to do is open up downwards because it's a negative, and also it's going to open up very steep because of the 4. So it's going to open up much more steeply than negative 1/2 x squared. So these are a bunch of different parabola you can have. You can also, with the bx plus c, you can have things that shift this way and open up in slightly different ways. But these are the basics. Let's see what else we got. Yeah, I mean, she talks right here with the width of them. This is the widest because it has a 1/4 there, so it's going to open up like that. 1x is about average, kind of like this maybe. A little bit less. This is actually 1/2. Negative 4 is going to be downwards and very steep. It's going to be shooting down very quickly, kind of like a very tight upside down A, like shh, shh. So you don't look at the sign of A, you just look at the absolute value of it, how close it is to 0. So if you had 0.001A or 0.001x squared, that would be opening up way wide like this. If you had y equals 600x squared, that's going to be super tight like this. Cool. Hope that helps, guys. This is a little bit about just an introduction to quadratic graphing, which we're going to be doing a lot of in the next week or so.